I'd like to introduce Tom Shiro. He's from Improving's Minneapolis office. He's in the data engineering space, that's obvious. He's been with Improving for 3 years, and today he's going to teach you about the analytics engineering role. Take it away, Tom.
All right, thank you. Appreciate that. All right, welcome everybody and good afternoon. Again, it was already stated, we'll be talking about the analytics engineering role. And it's a new emerging role that we feel is very important to the data space. And here we go. Today's agenda. Today, we're going to go through a few different aspects to try to build a case for what this new role is and how it fits in with our existing team setups. Basically, we're going to first go through a new role, new mindset type of I'm going to basically ask people to be open-minded about the possibilities being presented to you. And I think that's important because the data space has a lot of nuances that we need to discuss today. We will obviously go through the state of our data professionals and our projects. What is happening at our client site? And what kind of struggles do we have today? What's the reality of that? I will also visit into the teams and the modern data platforms. That's going to set the stage for starting to understand a shift that's happening in basically for all data professionals. We'll put it that way. We're going to go through the principles of data engineering because while we understand that from a data engineering perspective, it's important to know that those principles as well as architecture principles are what is going to drive the ability for us to be successful in whatever role comes next. And we're going to go through the origins of analytics engineering, which is pretty interesting. I feel that the company that coined this phrase probably was thinking of the future in a very well manner. We're going to compare the data analytics role with the data engineering role, but it's also important to understand that the analytics engineering role, we're trying to fit in to the point where it actually overlaps with not just data engineering, but analysis. So there's a lot going on there. And again, we're going to look at what this means for Improving as a whole. We want to know why is this happening and why does this need to take place? How does it help our clients? So that's very important as well. And then, of course, as stated earlier, I will summarize what we've talked about and then open up the floor for a little bit of Q&A. A little bit about me. My name is Tom Shiro. I've been with Improving for 3 years. I'm a principal consultant. That role primarily is where analysis meets data engineering. Imagine that. And I have about 20 years of data and integration solutions. And I've held just about every data role that you can think of. And I've noticed over the years, things such as skill gaps, misunderstandings about building robust solutions, or even how to hire the correct person for the right job. And I often say that while technology has gotten better, we continue to struggle with some of the same problems. And myself and my leader, Don Sawyer, both run meetups called the Twin Cities Analytics Engineering Group and the Twin Cities Data Engineering Meetup. So if you attend any meetups, you might want to join those groups as well to get a little more perspective in these areas, analytics and data engineering. So from new role, new mindset. Okay. With any new suggestion, there's inevitably some questioning, some resistance or pushback to understand what is this role about? Why is this change happening? And I would encourage everyone to have an open mind on the ideas presented to you. The information is based on client feedback. So mainly this is from the perspective of either sales calls or client feedback on individuals that has come into our office. It's also overseeing dozens of projects and looking at both the successes and the failures and why a project may or may not have been successful or have failed. A lot of times we analyze our skill sets, we try to understand missed opportunities, And then we also understand the career outlook and what is just happening in our industry as a whole. And the goal is to basically align our company so that way it meets the staffing needs of our clients, our project goals, and the reality of technologists and the type of people we hire and what type of role they fit best in. So the other thing is, while you're listening to this, try to identify and relate to either what gaps I present in your own project, or maybe some gaps that I've missed. In addition to that, you can discover opportunities to grow your skill set. We always know that when we look at a job description, it's filled with so many different qualifications, everything from Python programming to communication and collaboration. So there's a wide area of opportunity there to grow in your own skill set. And understand skills that complement your experience. I know that a lot of times when I'm thinking about hiring somebody for my project, I look for skills that complement mine versus an exact match to mine. And of course, empathize with your clients and companies and hiring managers. We, as technologists, we're trying to understand the whole landscape of the data space. It's very difficult to understand and know how to move forward. And you can only imagine the struggles that clients and companies and hiring managers go through to basically meet the project needs. And some of the goals of this conversation is to provide our clients with solutions to their needs based on their feedback and sales calls, again, enable data engineers to work on projects they love by providing a role that complements their skill sets, while also enabling data analysts to grow more into an engineering role that aligns with their experience. And we also hope to round out team skills sets so that all our bases are covered. So that way, when we are at a client, all the needs that are met within a project, we can actually fulfill. And also in addition to that, we're hoping to promote a lot of skill sets that we already have, but aren't as well known, at least in the Improving Minnesota office, such as data visualization, data governance, modeling expertise, and modern approaches to data warehousing. So there's a lot there. And so let's go through the state of data professionals. Let's just look at this. I will kind of say that some of this is going to sting a little bit, but before I want to reiterate that this is based on feedback, based on experience, and I'm in the data space with you. So this is not what everybody else is experiencing. This is what I've experienced and contributed to as well. The current state of data professionals is marked by rapid innovation, and is driven by the increasing need for companies to be data-driven. And that hits all processes in all industries. We see things such as talent and technology being very expensive to clients and employers as well. If you do the math and think about how many technologists exist in a department, take those salaries and multiply them out, it is considerable amount of salary and expenses. Project timelines are long and often extended. In fact, sometimes project timelines are long, which can be expected because they are complex. However, they may actually take longer, or even the timeline can be extended to the point where we often feel, how did we not know that the timeline needed to double? Communication and collaboration. This is really interesting in that it's difficult to have that collaboration and communication, not just because it might be difficult to understand each other because we have different mindsets. It's also difficult because everyone's busy. Who has time to sit down and talk to a person and help them understand the business objectives, or from a skills set, how to actually model something, or maybe how to develop something? There's a lot in there as well. Obviously, a lot of what we're seeing today, improving, I consider ourselves data pipeline experts. We're phenomenal in the pipelines we build. And quite often when we're asked to go to a client, it's because there's never-ending maintenance to their existing data pipeline, which means it may not have been designed in a manner that's easy to troubleshoot or easy to fix and modify the pipeline to get the achieved results, basically. We know that hiring can be difficult, knowing the type of person and the type of skill set. And we've seen those job descriptions where they're very, very long. And then there's also the information overload. We all read books and blogs and watch training videos online, and it can be difficult to translate possibly what I've read and what I understand about developing a pipeline or implementing a solution compared to what somebody else read. And that's where information overload can actually help us drive a better discussion, but it's also hard to pivot very quickly and understand the right course of action without extending that project timeline. And then, of course, there's always the skills gap. We see that there's a lot of engineers that may know Python and SQL, but they don't necessarily know Scala, or they don't necessarily know Power BI, or maybe they don't have a desire to work in that, but we're asked to have a wide skill set. And then also there's a big desire from our clients to have standards and best practices in place before we get to the client. So we know that sometimes we're hired to be a staff aug, and other times we're hired to own the entire solution. And that's where best practices, standards, development patterns, all that is really important when we go into a client so we can hit the ground running and deliver a solution basically very quickly. So when we look at modern data platforms, if you look at this diagram, there are a lot of different pieces in here. There's you have the data ingestion, and you have both in data ingestion, you have the low code, but you also have things such as Kafka and Confluent and Apache Spark. So you see there's a wide range of tools that can be from low code to a lot of infrastructure and a lot of coding necessary. So within that, you have batch processing, you have stream processing. There's a lot to consider here. In the data storage, you have data lakes, data warehouses, and then you have hybrid approaches such as data lakehouses that is made popular through Databricks. You have observability we need to know, data governance, security, and there's a whole list of data processing and transformation tools. And now they are broken by component. So extracting data is its own tool. Loading the data may be its own tool. And in addition, the transformation is its own tool for things like dbt that's gaining a lot of popularity. In addition, you have the data analytics and BI. So now that is really interesting because some analytics can be very in-depth, where you need to use TensorFlow or PyTorch, or you may need to use Python to basically analyze the data. Other times you're still using tried and true Excel, or you might be using Power BI, or you might be using a notebook or something. But the idea is there's a lot of ground to cover here. In addition, there is the data integration and orchestration. So you have tools such as Airflow, Dagster, Astronomer. Those are a lot of tools that you need to know. And they all have slight nuances that are difficult to detect without experience on a project with those particular tools. Now, a lot of this provides a lot of features and benefits. Obviously, they're more scalable. You can have a loosely coupled design, so that way you can almost plug and play. If you don't like Fivetran and you decide to go with, for instance, Airbyte, you can make that switch if you desire. If you want to go from batch processing to real-time processing, it's capable to do that. The idea is to save a little bit on costs. I don't know how much of a reality that is, but that's one of the things that we're trying to have happen here. And then there's accessibility and collaboration. a lot of times these teams have to work together because the pipeline is so large that you may be part of the extraction team, but not necessarily part of the transformation team. And that's where communication and standards and principles really come into play, so you understand what you're implementing. And there's a lot of use cases for this. You know, you obviously have healthcare with real-time patient monitoring. You have fraud detection with finance. In retail, you might have things such as behavior analysis to determine when a person buys something on a particular day or a particular month. And it goes way beyond the analysis that just knowing that, you know, during Christmas season or during a sale, you expect, you know, sales to go up. And then with manufacturing, supply chain optimization and quality control, that is very important. So modern data platforms are pivotal in transforming how organizations manage and utilize data. There's another component to this as well that I find interesting. First, all these components have connectors where they play well together. So I'm seeing that a lot, where basically, like I said, you can plug and play a lot of these technologies together. The other thing I'm seeing is we're starting to see a shift in a lot of the technologies, such as dbt or Microsoft Data Fabric is a really good example, where you're starting to see that some of the work being done, you may not need to be an expert in data analysis. You may not need to be an expert in data engineering or platform engineering. Instead, you need a broad range of skills, so that way you can manage and start to think about what's happening in your data pipeline as a whole. And you might be the same person loading data from, say, Snowflake, or pushing data to Snowflake, as you are building the Power BI report. And that's really interesting, because we're starting to see that the technology is starting to follow the desires of companies to have talent be able to be multifaceted. And when we start to look at principles of data engineering, here are just a few. Obviously, there's a lot, and you can either add or remove a few things here. But in general, when you think of data engineering, the focus is on practical applications of data collection and analysis. It encompasses a lot of disciplines, tools, and methodologies to build systems. And the principles of data engineering guide professionals in creating robust, scalable, and efficient data systems. So when we think of an engineer, the first thing we think is data quality. We want someone that can test data for accuracy and completeness, consistency, timeliness, and reliability. And this is even within the data quality space, there's everything from the low code, just creating something that can test data very quickly, maybe testing a data type, or is there a missing value, null and not null, to unit testing. So we go from simple to very complex very quickly. In addition, there's obviously pipeline development. We're starting to see, again, analysts get involved with pipeline development. We're starting to see data engineers being experts in pipeline development. And that whole ETL, ELT process, just that switch between ETL and ELT, it actually changes the mindset of somebody building that pipeline. And of course, you want it to be interoperable, meaning that you want to ensure the data from different systems can be integrated seamlessly. And you want a loosely coupled design. When it comes to whether you're doing low code, using a macro, using a YAML file, or using Python, modularity is very important, and reusability, because you want to be able to break down your systems into smaller reusable components. So not just the component of buying an extraction tool, but what happens within that extraction tool, and what knowledge do you need to know in order to successfully get that data to its destination. Automation is a big one. I've seen a lot of automation when you talk about orchestration, such as with Apache Airflow and Prefect. I've seen a lot of monitoring and observability and alerts coming into play self-healing systems, we used to have to design those ourselves. Now it's really just a design pattern, and these tools actually allow and facilitate self-healing systems. And there's also, again, there is a simple version of doing automation. For instance, using, let's think about this, your data catalog, or your the metadata you have, or source system information to actually drive some of the validation you do and the queries you create in your transformation tools. So there's a lot of space in each one of these points to kind of grow and realize there's a lot of nuances here that an engineer needs to know. Obviously, performance and optimization. We want data to be accessible, and we want the data in a real-time fashion. The quicker we get it, the better. All right, so let's try to take a step back and look at the analytics engineering role a little bit. So initially, this was a term coined by data build tool DBT, and it's gaining popularity on LinkedIn, blogs, and our industry as a whole. So if you've done any querying, or you want to look up on LinkedIn, or just look up blogs, you will see that ThoughtSpot, LinkedIn, Medium, let's see if I can think of anything else, DataCamp, all these websites are starting to get an interest in analytics engineering. So we want to understand what it is. But at the same time, overall, when DBT coined this term, it was really just saying analytics engineers provide clean data sets to end users in a way that empowers them to make data-driven decisions. And the other thing that was really interesting that I found kind of challenging for me at first, but I began to kind of agree with it. DBT said that today, if you are a modern data team, your first data hire will be someone who ends up owning the entire data stack. And I had to take back to that because while it sounds appealing, what does that really mean? And I started to think about, engineers that, utilize data ops principles, and they want to create efficient data pipelines. And how do they really understand every aspect of the data pipeline if they don't own it? And this goes beyond, and we'll start to talk about the details of the analytics engineering role and what they do. But if you think about it, how would a person ensure that data quality is basically adhered to? We know that a true data quality should be tested at each stage of the pipeline. And to oversee that, you usually need someone to watch the data pipeline. Or how about naming conventions, standards, best practices, or development patterns? How do we know those are being adhered to throughout different teams if basically we don't have somebody owning the entire data stack? And there's a lot more to go into, but if you want to know how code is written properly, making sure that data assets are governed and secure, and things like that, and reutilizing automation techniques, like I mentioned before, like metadata and data catalogs. You can actually reuse that in each layer of your pipeline. So there's a lot there that is very valuable. And I started thinking, okay, there is a possibility that a person could own the entire data stack. And I started to understand that in order for a pipeline to be successful, it became more of a reality than a nice to have. So let's try to look at analytics engineering by first comparing to the data engineering role. So it's important to know that these two roles complement each other. In addition, the analytics engineer, not shown here, but actually complements the data analyst role. And just like the data engineering role complements the software engineering role. So what we're seeing is the need for some overlap, but we also have a desire for distinct capabilities that possibly a data engineer doesn't have time to do, or maybe they're not interested for their career to actually work on a particular technology or type of tool set, where an analytics engineer is more inclined to work on, say, a Power BI report, as well as data governance, as well as your data pipeline. So A data engineer, and this is a great image, it really sums up everything that needs to be said by Don Sawyer. It was great. Thank you for this. Data engineers are passionate about systems and problem solving. So that's first and foremost. Where analytics engineers, they're more passionate about business value and improvement. Those are two different things. It's important to know that once you get to principal level or director level, or you become an expert in your field, you will see much more of an overlap. It's just going to naturally happen. But some of the things that are different is, so analytics engineers and data engineers, they both transform data. They might use code, they might use SQL. More often than not, a data engineer is capable of using Python and other code, where analytics engineers usually adhere to SQL. Analytics engineers need to be experts in data modeling. And they may actually be involved with things such as exploratory data analysis. That's where there does open up the opportunity to use a little bit of Python and things like that to actually drive out some analysis of your data that you're viewing. Data engineers, they may be more involved with advanced problem solving and infrastructure and solution engineering, where an analytics engineer, they may sit back and see a problem and they start to think, I see this as a problem interrelated with teams or interrelated to how we are structuring our pipeline as a whole, where the solution engineering is much more deep technical expertise of solving those technical problems. And what's really great is both roles need to utilize their skills of data ops, which crosses the line between process engineering and solution engineering in order to solve problems and design solutions. And let's try to go into a little bit of maybe like the scope of work, thinking about that. So data engineers primarily focus on technical aspects of like data infrastructure. They ensure data is collected, stored, and moved efficiently, while analytics engineers focus on transforming and modeling data to make it accessible and useful for analysis. And they bridge the gap between data engineering and data analysis. From a tools perspective, data engineers use a wide range of tools. They know typically a few different programming languages and technologies for big data processing, data integration, and cloud services. Analytics engineers predominantly do work with SQL and data modeling tools, but they also move into data visualization platforms. Collaboration. Data engineers work closely with IT and software development teams, where an analytics engineer works closely with data analysts, data scientists, and business stakeholders. And the end goal is basically data engineers aim to build robust data pipelines and infrastructure, and analytics engineers aim to deliver actionable insights and data products that support decision-making. So that's a lot to kind of digest. And a lot of times after this slide, someone may feel that, aren't we already doing that? And I understand that. There are a lot of data engineers that cross over into being an analytics engineer. And there's a lot of analytics engineers that start to cross over a little bit more into data engineering. And quite honestly, we have so many skills that are needed at clients, we often feel that we're just doing everything all at once. These two roles are designed to complement each other and also utilize our skills so that way they drive out the best results for our client. For instance, I'm an analytics engineer. I totally look at solving problems less from code and more from going to the business analyst and saying, help me understand what I'm seeing. It's just two different mindsets. They're both valid and they're both needed in the data space. So let's take a look at Improving's modern data team. Okay, this is really great because we're already seeing a shift in a lot of the industry, and our modern data team is already skilled and ready to adopt an analytics engineering role. It just so happens that we might restructure things and add tool sets that we will support or use in implementation. However, in modern data alone, we have the data engineering, we have enterprise data strategy, we have machine learning engineering, data warehousing, obviously, and we have data analytics engineering. But this goes beyond just high level. We have all phases of that, from the consultant level all the way to the technical director, where people can specialize in these areas as well. In the data space, we also have platform engineering, AI and machine learning. And I do mention business agility and product delivery, because in normal fashion, some of an analytics engineer might work with business agility, and the data engineer might work more with product delivery. That just naturally happens where everybody overlaps. And we even have a Scrum Masters and project managers that a lot of times we see technologists overlap into. Now, what does this mean for improving as a whole? This is where it gets really fun and very interesting quickly. So the first is the analytics engineer. We would really like to see own the entire data pipeline. Now, having said that, it doesn't mean they need to be the person that does every aspect of the data pipeline. Instead, it's an overseer and a person that can understand exactly what's happening at a client site and own that data pipeline. And this is very important because, again, going back to what clients perceive, some clients do just want someone that is staff aug, and they just need some help getting a project implemented. Other clients really say, we want you to own this. We want somebody to implement this data pipeline, and our team will follow your recommendations. At that point, you start looking at things like a lot of standardization, which I have down there, meaning you start looking at utilizing data ops, working in between teams. You're cross-functional between business analysts and business objectives, and also data engineers and infrastructure and platform engineering. You need to understand all those. And from that mindset, you don't have to have the ability to necessarily code in all those aspects, but you need to understand it and be someone that has a wide skill set versus an expert skill set. It also means for improving, we have those that are interested in data governance. Now, someone might say, well, how does data governance really play a role in engineering? But if we really look at it, when we look at the data cataloging, the data lineage, the access control, and the compliance, you're starting to bridge the gap. As long as you're not a leadership in like thought leadership, you're starting to bridge the gap where you really need someone that can talk technical aspects with some of the developers, while also reusing components that you already have in place, or applications or catalogs you already have in place. And by doing that, you need, again, a lot of wide skill sets that allow you to do that, and engineering is one of those. Data modeling expertise. So this is going to be a big one. We're seeing that data modeling is starting to make a comeback, but it's quite interesting in that it's starting to shift into things such as Data Vault 2.0. And dimensional modeling is not quite the same that it used to be. It is dimensional modeling, but more appropriate for what maybe Snowflake or Redshift expects in that modeling. So there are nuances in there, which means that somebody that is a data modeler would look at being an expert in that area. You have canonical models. And then, of course, conceptual, logical, and physical models. And there's probably even more to that if you want to include, say, modeling for NoSQL systems. When it comes to standardization, again, what this means is we want to be able to walk into a client and say that we will help you establish a common vocabulary for your business. We want to enforce naming conventions, development patterns, and expectations around pipeline development. For instance, when should you, and probably the answer is always, place particular unit tests or data tests in your pipeline? And the answer would be breaking down your pipeline in the smallest components and starting to analyze how you can ensure that that data quality exists, that the data arrives in a particular time frame, and you're alerted if anything goes wrong. And that's where this engineering role for analytics engineering starts to sound like architecture, starts to sound like analysis, starts to sound like engineering. Again, we're all hybrid roles, but that's exactly what we're seeing. And then, of course, modeling standards. We often find that modelers have their own standards. The development environment or the engineers have their own pipeline standards, and then the business has their way of viewing their domains. And the answer to that is it is possible with someone overseeing these areas, and there might be multiple people, it might just be one person, but by overseeing these areas, you can start to have your models look like the business domains. You can start to have your pipelines look like the business domains. The naming conventions, the development patterns are very easy to understand. And the goal is if somebody's new on day one and they sorry, I got a notification. If they basically look at your pipeline or look at your data models, they understand what the business is. They understand what they need to do to be successful to build that pipeline. And of course, another thing that while some of our, like for instance, some of our different branches like Omaha, Improving, they do have data visualization, but we're hoping to bring that into the Minnesota branch because we have people that are very skilled in building dashboards and building reports for relevance and clarity, which is fantastic. The next part is this exploratory data analysis. I'm very interested in this because this is where you start to really evolve your analysis skills and provide visualizations that can actually test hypotheses or drive out when to use this particular chart or graph or plot and identify patterns. So this is where it does get a little more involved, and analysts would love to grow into this area. I would. And then, of course, we will always help companies with defining clear objectives and basically making sure that what the business wants, the business gets. And that's really important because basically the truth is the business drives technology. It's not technology that drives the business. And we've seen that through the evolution of our modern platform tooling and things like that. What this means specifically when looking at all this, and I do want to mention that this is an evolving role, which means that it's not fully baked out. We don't know where it's going to end up. This is a good starting point. Who's really going to drive this, even though I've mentioned a few bullet points of what we're looking to do and improving, because we have people with these skill sets, it really comes down to the client. If the client is more interested in somebody owning the entire data pipeline, that is something we will consider, obviously. We do know we get a lot of that in data governance and data modeling and standardization. Those four are probably the most talked about requirements that businesses are looking for. And I kind of want to give a few use cases off of the analytics engineering role, because it's important to know that within these solutions, there are low-code solutions. There are very different aspects. I'll give you one example. So at a particular client, we are looking at utilizing a low-code solution in order to migrate their data. Within that migration tool, and I won't mention it or the client, but within that migration tool, we have to understand how to effectively extract the data, provide data mapping, so that way it maps source to destination. We have to analyze the data to understand, do we have duplicates? Did we get all the data points we needed? We need to troubleshoot and validate and ensure data quality. In addition, we may need to report on the data to discuss different aspects of it through different teams. And that's where visualization comes into a key component. And we also have to build reusable components. That way, the same tried and true approach in our components is reusable and understandable to the next person. And we also need to understand from beginning to end the entire life cycle. And this is very interesting because we will also work with business stakeholders to understand their metrics. What are they trying to accomplish? What data points are they looking at? Which means we have to work with stakeholders at the source system. We also have to work with stakeholders at the destination where we're going. And what that all really sounds like is an analytics engineering role. So you need to apply engineering principles. You need to have good communication skills, data visualization. Your skill set is very wide, but because it is a low-code solution, you can maybe not, you may not need as much Python. You just need to know SQL, for instance, or how to extract and move data and that analysis and detect anomalies or bad data. So it's a very analytics role, but to own that entire, migration pipeline, you also need to adhere to, I understand how to build a pipeline, even though it's going to be based on point and click or SQL. The next use case, which I just love, I'm really interested in the Microsoft Data Fabric. This is where analysts are truly expected to be in the engineering space. However, the Microsoft Data Fabric offers low-code solutions where it's point-and-click ETL, but you also have the ability to use Apache Spark, or you can use PySpark to actually load data. And what you're trying to do is, with Microsoft Data Fabric, is basically have a one view, one solution to build your visualization and derive your actionable insights of the data you have. So that's very interesting because you only need to know a little bit of PySpark. As far as I know, you don't need to know too much, but you also need to know how to build systems. And you need to know how to integrate with Databricks, Dataverse, Snowflake, and of course, Power BI. And we're seeing that technologists are starting to need the skill of understanding data engineering principles right from out of the gate, and they need to know how to build data architecture so that way they understand basically how to build a solution. And we're seeing that quite often. And that's going to continue to grow. And as tooling becomes seemingly easier to utilize, we know that the reality is some of these tools have such little different nuances that they are hard to understand. Just understanding sometimes the difference between a data lake, a data lakehouse, a data warehouse, a data mart. Even just getting to that point, you're really starting to cross over concepts, and you can get lost in the details very quickly. By separating these two roles, you start to allow the analytics engineer to concentrate in one area and the data engineers to concentrate in a different area. While both these roles are essential to, there we go. While both these roles are essential in a data-driven organization, data engineers ensure the data is collected and managed efficiently. Analytics engineers ensure that the data is usable and valuable for analysis. And you're able to make data-driven decisions. They do complement each other. The analytics engineer also complements the analyst and provides a foundation for analysts to grow into the engineering space, as well as, just like we see a lot at Improving, where some really sharp, skilled software engineers are now interested in moving into the data engineering space. So we're starting to round out these skill sets so that way we can become experts as an analytics engineer, just like we are in the data engineering space. And I would consider the pipelines we develop to be excellent. I mean, expert level, they're phenomenal. And I think that's why a lot of clients come to us and basically hire us to do some of the work. But again, this analytics engineer role starts to fill in the gaps of the other questions that clients have and the other requirements that they have before they hire us to bring on a team. So having said that, I pretty much wrapped up the presentation. Again, this is an evolving role. The clients and the industry is probably going to drive a lot of where we go from here. But it's very important to know that if you're a true data engineering professional, you don't need to go into analytics engineering or vice versa. But essentially, it's also important to know that data engineers and analytics engineers, depending on the client you're on, or even the role you are if you're a full-time employee, you're going to see those skills overlap more often than not. So yeah, I will open it up to questions and see if, or even thoughts, even if you have, some comments.
Yeah. If you have any questions, please type them in. We'll grab them as they come in. I had one that popped up from myself, is that obviously, since we have expanded into data engineers or analytics engineers, there must be some value in having two different people fill these two closely related yet still different roles. Is it because of the difference in priorities, that one serves the data, one serves the business?
Sure. So I can answer that. So what we're seeing is, from a personality standpoint, we're seeing that data engineers love to code. So that's the first thing. And they quite often may not want to go into low code solutions. So that's just the reality of things. But what we're also seeing is, when a data professional needs to stand on their own 2 feet and they're going into a client by themselves, more often than not, they need to have some capabilities as an analytics engineer, because they're not going to just be handed requirements and tasks and they can live off in their own space. Now, that's not to say that data engineers don't integrate well with business stakeholders. It just means more often than not, when it comes to long meetings, long discussions, and business stakeholders that don't know what they want, that's where an analytics engineer can really shine and stand on their own 2 feet and basically provide an entire solution. Now, that's part of it. The other part is the loosely decoupled way of looking at your project. So if we were to break down, it's not just extract, transform, and load or anything like that. Basically, within the extraction, there are multiple steps to get the data into, say, Snowflake or BigQuery. Once it gets to Snowflake or BigQuery, there are multiple steps to get it to the next stage and the next stage. And quite often, those are different teams. Those different teams, you lose sight of what's happening in between those teams. And quite often, when I'm working and an analytics engineer isn't overseeing the pipeline, what happens is, I don't know the data I'm being given. I just know the task I'm trying to complete. And I may not know how that affects the next person in the pipeline. And that's what we're seeing. So a lot of times the analytics engineers are a little bit more having a wide skill set, and they're able to adapt to many different things happening at the same time, where the deep expertise occurs when you're a data engineer. And for instance, if somebody needed to code something very complex, you probably wouldn't ask me. But at the same time, if I'm in a role where I have to do that, then I'm going to do that anyway. So there's a lot going on there. But in addition, it helps us because the little fringes, and again, plugging those little pieces of information that we're seeing clients ask for, is no longer just pipeline development. It's how do we govern our data? How do we implement data lineage? How do we integrate with other teams? And that's where it's very difficult to have one person doing that role in an enterprise fashion. So hopefully that answers your question. I think when you're at a client, you'll start to see that if somebody owns the entire pipeline, they also very rarely are working on more than one aspect. So the same person extracting the data may not be transforming the data, even though they have to understand the whole ecosystem. So hopefully that answers your question.
Yep, does make sense. Thank you.
Yeah. You know, yeah, go ahead.
Oh, you go ahead.
Okay, so a lot of times I've been asked this question. What makes an analytics engineer considered an engineer? Because we're starting to cross boundaries between analysts that are not engineering yet, but they also need to know engineering principles. So the first is the engineering mindset. Analytics engineers approach problems with an engineering mindset, focusing on designing robust, scalable, and maintainable pipelines. So that still needs to take place. In addition, from the data modeling perspective, they create complex data models that represent business processes and support their analytical needs. In addition to that, that data modeling and those analytical needs and that domain knowledge needs to transfer into the naming conventions and the standards that the data engineers use. In addition to programming, I mentioned the exploratory data analysis. So while, again, we might use SQL and we might use Excel, that is primarily our tools when it comes to analysis. However, we might need to use Python or R for different transformations or visualizations. And obviously, we all need to know version control, but this is a really good aspect, a really key component. We need to know and understand and troubleshoot version control issues as an analytics engineer. But if you're looking for somebody that maybe from start to finish wants to go into Azure DevOps, for instance, and you want them to build that CI/CD pipeline, you're looking more for a data engineer because that's a little bit more in line with their skill set. And quality assurance, everybody has to do that. Modularity, repeatability, QA, unit testing, data testing, end-to-end testing, all that has to be done regardless if you're working on Power BI or you're actually extracting data. And so there's a lot of different things in that. And the engineering challenges, for instance, analytics engineers tackle complex problems as well. And they need to have innovative solutions that apply analytical thinking and problem-solving skills typical of engineering principles. Quite often, analytics engineers might need to come to a quick solution on solving a problem that might be related to the process we're using as far as the people process or the teams that we hire, where a data engineer may, think more in terms of, I need to fix and performance tune this particular set of Python scripts because it is performing badly or there's something wrong with the data. So there's a lot going on there. And overall, there's almost no way you can overlap skills without understanding what an analyst does, what a data engineer is good at, just like a data engineer quite often has the software engineering skills as well. So that overlap is very important. Yeah, so that's one reason why, there's a few reasons why, this really is an engineering role and it's not just business intelligence. It's not something along those lines.
Alrighty. Well, I think you explained it really well. We haven't gotten any questions during that, so I'll assume that there are none out there. For next week, next Wednesday, July 17th, we are presenting Separating the Bricks in Databricks by Tom Buxton. And hopefully we will see you all there. Thank you very much. Hope you all have a great day, and we'll see you next Wednesday.
Thanks,
Bye.
everybody. Have a good day.